I'm happy to greet you too. Good evening, everybody. I was really surprised that such a large crowd of people were interested in our presentation, because today we don't announce a new ICO, we don't disrupt all these insurance companies, but we show a small case with a small solution. But it's a solution, and we will also present a demo of our solution. So I spoke with Andre, the host of this meetup, and to say him I would want to see something that is real functioning, and I hope we could do that tonight. So I want a little bit to know what you are about. Who is from the business side? Who is more from the technical side? Okay, it's maybe half. Who's from insurance business? Okay. Who's from healthcare? Health, little less. Who lives in Switzerland? So you should know, about 1/6 of you should know the name CSS. Who knows CSS? Oh, that's fine. I will introduce our firm at a short time again. So I like to introduce Christian. He is my co-speaker, and he is, I have to say, the implementer of the whole thing. I'm a little bit of the supporter and manager, and I established the possibility that we could do that. Christian is a developer at CSS. He normally is developing web applications or back-end applications for our agents, but sometimes he's going to hackathons, and every time he goes, he wins a prize. And I have to apologize our third member of the team, Michu, because maybe he just got father these days, this moment, so his wife won't let him travel from Lucerne to here. So all the best for him for these days. So a little bit about CSS. You can see what we the main features. We have a transaction volume of 6 billion Swiss francs. The health insurance business is financially big. We have also more than 200 developers, system engineers. We were one of the first who had relational DBs in the late 90s. We had object-oriented DBs. And perhaps we are the first to move to blockchain as persistence layer in some cases. We have a service-based architecture. We make Scrum. We have Java, Java E, Angular 4. We produce prize-winning apps. This is our MyCSS. Check it out. Won a prize this year. And if you're interested, the developers, we are hiring. So that's the abstract we published for this presentation. So I hope you don't expect anything else. That's what we promised for this evening. And the menu of this day is, as a starter, I will introduce the use case, that you really understand what we have solved. Then there is a small but fine appetizer. We show the demo of the application, that you really are interested in the main dish, where Christian will present the technical solution in detail. As dessert, I draw some conclusions then. So what's the case? The case is a very regulated case in health assurance. Health insurance in Switzerland is US obligatory, so everybody who lives in Switzerland should have a health insurance, and he is not allowed, or we must prove as an insurance company that he has no gap when he changes an insurance. So the insurance terminates only if the new insurance company has communicated that, for example, our avatar, Tim, has a new contract and there is no insurance gap between the two contracts. So the following case, Tim resigns his contract for his insurance XYZ at the end of this year. So the contract remains pending till we get a message from the other insurance who will go to. In this case, if he goes nowhere, we have to insure him again. And then when CSS, when he goes to CSS, he is confirming the new contract, is starting immediately after these terminations without the gap. Then we can approve on both sides this contract. So this is the case. I will explain it again when I show the solution with smart contracts. So if there is a case, there is a current solution. The current solution is something like always in, or like often in the assurance, in the insurance, health insurance business, there are files. We exchange files on a base, maybe weekly, maybe a little bit more or less, but we exchange files, accepting files, sending files, and if you send files on a business where about 60 or 100 companies are around, there is an intermediary. So this intermediary has some problems for us. He wants more information than necessary. He's owned by a consortium of other insurers, and not all health insurers take part in this solution. Then there must be a second and third channel of information. If it doesn't work with these files, there are registered letters, very expensive solution, that are exchanged, or there are agents which make phone calls, mails, till we are really sure that we can take this person under contract. So you see, perhaps there are a lot of possible improvements. We think this process can be further automated if we get something more continuous, on a more continuing base. If we get every new contract is immediately messaged by us, or every termination goes to the other firm on a continuous base. So it may be cheaper. There is also a price we have to pay for each entry in this file. We have to pay a fee, and you see that's perhaps not so interesting if it can be done cheaper. And the classical case for some blockchain implementations, can we eliminate this intermediary? So we thought about how to design this little case with smart contracts. Before we went to the solution, there was a little bit of brain work that had to be done to think about the possibilities of smart contract and how this exchange could be done on this base, because you really have to think a little bit on another kind, programming smart contracts. So one of the main ideas is that every company every company, this is one company, XYZ, and this is one company, has two contracts. In one contract, there are the resignment the persons who want to resign, and on the other contract, there are stored the persons who want a new insurance. And these two contracts are held for every company that takes part in our solution. So how's the exchange of information? Again, Tim resigns from his insurance XYZ because he is not satisfied. The status on this contract will remain pending because this insurance can't give him this contract or can't cancel the contract at this time without having a message from another insurance. So the contract looks at every other company's contract of new insurances. If there is a Tim mentioned who has already a new contract, at this time Tim has only written his resignment letter, and there is no other company that has a new contract, so the answer is no, and the status remains pending. Then he goes to our agency or our famous website because he wants a real good insurance with CSS, and he met some nice people at the counter, and immediately he signs a contract with CSS. And also we can't give him this new insurance till we don't know that he have resigned on the other one. So we go and look at every other resignment contract to look up if there's a Tim who has resigned on this company. The answer for sure at the moment will be yes, and so both states can be accepted, and the message can be sent to both insurers to take the actions that now are necessary to start the process of resignment or new insurance. So that's the main idea to solve this problem with smart contracts. So we had to think about how we would, which technology we would use to solve this problem. And in blockchains, you have at least 3 questions that you have to answer. Who would participate in the chain? How are the participants identified? And who should be allowed to make new validations, new blocks? Who should make transactions? So this gives like a little bit of the DNA of the solution. We choose to make a consortium chain because we have a closed member group. There will only be health insurance companies. We have identified user. Each company must be identified because we must know to which company he switched. So we have to know this, and it's a permissioned blockchain because every participant will be an authorizer and will have the right to know the whole information of the chain. So after we have decided this DNA, we looked around for implementations, and we choose this kind of implementations. And the Ethereum as a base, because we had some knowledge. He already was familiar with this technology, but also it's really nice, and the developers like to get knowledge in Solidity. then there is a really good community out there, and this may be the main point for who speaks for this implementation. And there is also a POA algorithm that we can do this permissioned chain there. So we looked around which implementation are there, and we took parity as an implementation because also of the community and this POA algorithm that we wanted to use as proof of work. We use this consensus algorithm Aura, who is recommended also by parity for this kind of blockchains. So that's what we choose. And before we go to the technical details now, we will show a small demo, which I will click through, and he will point out the interesting things.
So we made a small UI, nothing fancy, just functional, to demonstrate this whole thing. You see here the two sides. In this case, Sanagate will be the insurance provider which Tim resigns, and CSS will be the provider where Tim will ask for a new insurance. So first thing we should do is to enter Tim details. Yeah, it's a social security number, the year when Tim wants to resign, and the contract number of the contract he wants to resign. So we generate a little hash. I will tell more about this later, and then we click to resign. So wait a moment to let the new block be mined. Yeah. And there it bubbles up, just a small notification we built in. It's just a notification that someone in the blockchain just mined our new block, and now the resignment is put into the contract at Sanagate. And it's pending, it's red at this point. So step 2, Tim wants a new insurance on our cool CSS insurance company. And here again, he gives the same data, the social security number, the year where he resigned, in most cases the current year, and the contract number, the contract ID of the resigned contract. And here again, we generate a small hash, and instead of resign, we ask for a new insurance. Wait a moment. There it is. We see it bubbled up again. It's just got mined in the blockchain, and the new insurance is inside the chain. And they're bubbled up 2 more messages, and what we see is just in this moment, both sides went to accept it. Yeah.
See here, it's also accepted. Before it was ausstehend.
Yeah. I think you need to refresh the right side. Automatic refresh doesn't work. Yeah.
Yeah, here it worked.
Whatever. Yeah, there it is. Okay, accepted at both sides. Yeah. But you also can see, just to verify that we are connected, we'll have a look at the parity UI. It's the native UI parity brings with his client. There we see the 3 contracts. I will tell more in a bit. It's the resignment contract, the new insurance contract of this side of CSS. Left the sign. Okay, and a mystery contract registrar. Yeah, and when we take a look at the signer, we see all that is mined. 3 minutes ago, add Kündigung, add resign, just worked. And on the other side, if we take a look there, we see add Neuversicherung, add new contract, add new insurance, work too. And what happened behind is this contracts just communicated with themselves, and yeah, magically it just got accepted. We will have a small dive into the technical implementation, into the technical details, just for sake of being flexible, and because it's a cool technology. We used Docker as base system, as base infrastructure system there. We set up Docker on top of Rancher OS. Maybe 1 or 2 people know this. And yeah, then we created 3 Docker containers. 1 Docker container for parity itself. It's just pure parity with some configurations. And the second one is the API Docker container. It's a little abstraction layer on top of parity, so that other people don't need to know the whole parity driver stack to communicate with this whole thing. And as a third part, we have MQ Docker. It's a message queue. I will tell later more about this. It's for the sake of being able to bring this whole thing into production, and being able to provide a way that transactions can go into production. Yeah. I mentioned it before. We have a little configuration, a little custom configuration inside this parity container. It uses parity 1.7.2, and we made a custom config toml file. It's used for path definements and custom addresses and so on. And the essential part is chain.json. It's used to configure our chain members and the whole algorithm thing. So we use proof of authority here in this case, and not proof of work. This is a place where we need to configure this. Yeah, the API and messaging containers, they're just little helpers for us to let's start this whole POC and bring up this pretty not fancy UI. In the API container we have Node.js, we have Express.js, we have Web3, the driver to communicate with parity, and yeah, we have a little front end, and we have a store using Redis there. And on messaging queue side we have RabbitMQ, which I think is one of the most used messaging queue systems. And yeah, just a side note, of course, you don't need to put the store inside this container. Of course, you can use your own store outside of this container, maybe in production layer. Yeah, the registrar contract, it's a special contract we designed just to being able, well, just to make the communication between the other contracts happen. The other contracts per default don't know each other. So we need some central place where they can get and ask for, hey, what other companies are around there? Hey, what are the contract addresses of these other company contracts, and so on. And yeah, this is a place. It's just a small registry. It holds all available providers and the lists of contracts, and it offers some small functions to add providers and yeah, getter and setter. That's all. Now, first things first, we need to bootstrap the first insurance company. What we need are these 3 prepared containers: the parity Docker, the API Docker, the message queue Docker, and these are bundled into one node CSS in this case, and we have our blockchain living inside parity Docker. There we need to add some contracts. We need to publish the registrar contract only for the first bootstrap, and we need to publish the CSS resign contract and the CSS insurance contract. Konrad mentioned at the beginning, all our members inside the blockchain are authorizers. All are able to read and write in the blockchain. So we need for each company an authorizer account, so that we have an address and hint who does what, when, why. Yeah, that's it. Adding another node. Straightforward, I think. You just need to copy the whole thing. You need to start these 3 Docker containers on the other side. They will group together and form node XYZ, ABC, whatever. The message queue Docker containers will talk to the other to the other message queue instances and build up a cluster. And parity Docker, that's one of the only steps necessary to make manually, in a manual way. You need to say parity, hey, you have a blockchain with 1 node, now I want to add another node, and you have to put the address, the ID, it's the enode string, into the global blockchain configuration, so that they know each other and can communicate with each other in a permitted way. Yeah. Okay. Yeah, and then we add then we need to add the other contracts: XYZ resign contract, XYZ new insurance contract, and the XYZ authorizer account. What we don't need to add there is a second registrar contract. I mentioned it before. We only need one of this. It's a central place where all other contracts will be registered and where we can ask which providers are in our blockchain and which contracts are held by these providers. Yeah. And then the final question, how to integrate this whole thing into production. Whenever an action happens inside the contracts, an event will be published inside the blockchain. The parity driver will give us this event, but then it's done. It's only a one-time thing, and now there's a problem. Production maybe wants batches of data, doesn't want to work, doesn't synchronize, doesn't want to work asynchronous, and yeah, it's a little bit difficult. So we added this message queue layer where all these events, adding a resign, adding a new insurance into the contracts, will be put in, and whenever we want to, we can just fetch a whole batch of this data from the message queue, and the message queue works over REST, over HTTPS, so it's secure, it's a standardized way, and it's an easy way. I think every developer can just implement a REST API instead of this Web3 API. Yeah, and production consumes this whole thing. Production can ask the API Docker over the REST API to add new insurances, to add new resign requests and so on, and put them into their own database. Yeah. So personal data is sensible. And as you see, we have a small data set which we ask the customer to provide us, and we don't want to save this in plain text into blockchain when everyone participating in the blockchain can read it. We don't want to enable a company to just ask, hey, Tim, where was he 10 years ago? Or tell me the history of all your customers and so on. We don't want to enable the companies to do that. So we need a way to prevent data abuse. What we are doing here is we only use hashes inside the blockchain. We store and contain only hashes on the chain side, and the hash is generated on a higher level on the API Docker from this minimal data set. So no real personal data is ever stored inside the blockchain. On company side, it's easy. You just can save this generated hash on the record of this customer, and then later you can just get the real data again on your business side. But only when you know this hash and only when you know this customer. So you only have the hashes of your customers, which are in the situation which are ask you to resign or to make a new contract on your side. Yeah, I tried to visualize this thing with color. I hope it's clear. Yeah.
So you are perhaps interested about the state of the project. As you saw, we have this contracts finished. The UI is in a state you can make it better, but the UI is also the part that is running finally on the side of the company. So if you go back to here you can run a UI on base of our API Docker container with any technology. You just have to open this connection to our API Docker, and so you can realize your own API, your own UI. So that's in a state we are ready to discuss with the customers which data they want there and how it should be appear on their screen. This was a point for me as a technology manager, was the one who at the beginning of this project I really wasn't sure how complex this is and how much automation you can do to that, to adding nodes in a consortium chain. And this was one of the results, that it could be done, but not we couldn't totally automate. We have 2-3 data that we have to exchange in the process of setting up this new node, but it's nearby. So I'm really happy, and I could say, well, this can be go to production, and we can offer another insurance to take part in a POC. So that's what we are planning. We have found, afterwards you have here an apero, and it's the idea is that you're going to network. So one of these meetups, I met the guy from another insurance company, and we talked together, and so I could convince him to make with us a POC, and well, I'm looking forward that we are going this year to this POC with the other company. What are the conclusions a little bit, the result of the whole story? As you see, you can, the technical problems can be solved. You can do such a small but interesting case with small contract in a really concise and small way. There are really not a lot of programming lines on the contracts. They are more on the UI side, but on the contracts there are really 100 lines of code you have to do there. So that this is really solvable. The development process is still a little bit clumsy. I look at some other people who work for us, and they also got some experience with that. But we had, this project was done in 2 hack weeks. We had one in the spring and one 2 months ago. We three went together in a room and worked for a week. And there was really an improvement in all these development tools between these 2 sessions we had. So we are looking forward that this will be better and better and better again. Consortium chains can be set up early and extended easily. That was, I was really skeptical, but this can be done with this implementation we have chosen. Security is achievable. That's what he shows in his last slide. And perhaps on the dark side, eliminating intermediaries may not be so easy. I will point out 3 points to think about. Intermediaries have shareholders. There are financial interests, and they are not so easily willing to get up their share. The second is, they set standards. They are the ones, and this is in this case really the benefit of this intermediary is not the transfer of the files, but he has set these standards for how these files have to be filled. So this you have to do here on your own, or who does this, or you need somebody who says this is the data, this runs like that. So that this is a leak you have to fill with blockchain technologies. And intermediaries are also used to guarantee governance. Here you have to convince your revision firm that he accepts this as a provable solution, and that may be at the moment not so easy. Well, as a conclusion, I can say every place you need to establish trust, enhance automation, prove immutability. You can look for a case in your business. We are looking at the moment at IoT devices, fitness center, fitness tracker, medical devices, and combining that with insurance products. We have some research pending on other business cases, also with private and public chains. For example, with connecting to IoT cases, which is held at the University of Applied Science Nordwestschweiz, where we are working together. So we are going on this fascinating theme, and I hope you get a little insight how this can be solved, and we are now ready to answer questions, maybe in German if it helps, or otherwise we try to keep in English.
Obviously insurance contracts there's many variations, so my question centers around what happens when Mr. Jones, who's single, had a contract for insurance, then he gets married, he wants to cancel that contract and then, get a contract for his family. Or case number 2, where Mrs. Smith has an insurance contract and now she wants to add maternity to the new contract. So how do you manage the variations of contracts on both sides and their identities?
There is no variation because this is the compulsory health system.
So it's all the same.
Yeah, that's just for this you have to do by obligation in Switzerland, and it's just for this because only this part is regulated in this case. That's KVG, the law article I showed at the beginning.
Following up this question. So I have 2. First
One
of
after
all,
the other.
your customer targeting group, for me, is really limited. Like how many people would the base insurance want to switch within Switzerland? Because normally you change it when you change the country. 200 something, and you don't really change. So
it's about a 250,000 to 1 million every year.
Okay, and then
Oh, just a few.
yeah, so this is your targeting group, and also only the people with basic insurance. So imagine you have the additional package. So you need one more step to validate the data. Because for instance, Tim has a cancer. I don't wish Tim has cancer, but in case he has it, and he switched to get more premium. So the new company have to really validate his historical data. Am I right? And in this moment, when you switch within 5-10 seconds, so you accept immediately the request, and maybe it's not a benefit for the future.
For this case, this is no problem. But you only put Tim to this GUI, I will say, when all these proofs are made. You first make on your system all these proofs, and if you have made them, so then you got this. You make a message to our system. So that's, for example, if he hasn't paid on his invoices, he won't be accepted on the other one.
And,
was the topic.
and whether he has cancer or not, every health insurance provider by law can't reject someone for this basic health insurance. That's by law provided.
That's exactly the concern. So your targeting group is only the base insurance, cannot be with the people with additional package.
No, it's just for basic health insurance.
Yeah, so maybe the second one, maybe stupid, but can you explain to me why you call this blockchain? Because it's a really centralized system.
I expected this question. So if you have a central DB, you have somebody who runs it, and I'm on the same problem as I am with files. I will a decentralized version, and I will easily, without any friction, to resign from this solution or to go to this solution, and perhaps I don't want to put data there that I don't want to get knowledge to this intermediary. I won't get rid of them. That's the basic idea.
Yeah, just a fundamental question to your business model. You're targeting basically basic insurance, compulsory health insurance in Switzerland. My question is that company agnostic? Is this system enabling everyone to be able to participate? Let's say if I'm from CSS insurance and I want to switch to something else, or are you actually providing a system, business model to enable others to switch over to CSS?
It's company agnostic. Every health insurer who has basic health insurance can use this system. It's just here we need to know the name for that we know where he's gone to. And also you can think that's the nice thing with smart contracts. It's a problem behind we have solved with changing any contract without interruption, and you can use data from any other system you want to use. That's a little bit the charm of smart contracts. There was a question over there.
Yes. Yeah. First of all, it was like a really nice pragmatic solution to the problem. I'm Swiss, so I know about changing insurances and yes, the hassle. My question is, maybe I'm a bit naive, but what is the legal framework for such contract at the moment? Is it recognized legally, like those smart contracts? If I
don't understand what you
My question is just what if tomorrow you get all the other insurance company on board with that? Is it going to be accepted on the eyes of the law without any problem that this is a proof that you changed insurances and that there was no gap, or has this central authority at the moment some kind of legal role as a guarant of this
I think only for the revisioners. The FINMA, that's the FINMA of the insurers. Perhaps you have to prove them if they get skeptic about the solution.
I mean, today they use phone calls to verify. So
yeah, okay.
How positive are you that you can get rid of the intermediary? And what's the key thing you think needs to happen
That's what I said. We are not part of this consortium who runs this intermediary, so he can go to whatever. There are in Switzerland two main consortiums, Santé Suisse and Cura Futura, and one will be better than the other, or there is concurrence between them. So perhaps you could, with a solution like that, you can be behind this scene, because it's a neutral solution. Nobody gets some financial profits out of them. Nobody has some power to change the rules.
What do we think it will happen in the near future, 2 to 3 years, that the others insurance will move to such a system?
I think it has to be enhanced with other functionalities that it is used. That is just the basic functionality.
Every insurance admin and every person who's purchasing insurance, shouldn't you have a global encrypted identifier along with two-factor authentication before you access the system? We have a solution. We have a solution.
Maybe. Yeah, we profit from that, but
yeah, what's exactly your interest in doing that? I mean, you're certainly running a risk losing customers fast.
Pardon?
I mean, the idea is making a switch very easy for everybody.
No, it's really eliminating the intermediary. It's not public. It's just for the insurance companies to run that.
But
it's not for you.
If someone wants to change this insurance, you make it easier for those people.
yeah.
No, for the companies, not for the people. The companies can do more automation, for example, because they get immediately a message after it's accepted and things like that. At the moment with these files, we have to wait. And
A question with regards to whether or not you need all the companies participating in this system, because otherwise you get like pending events that are out there. And is there a mechanism to address that? If like somebody does not participate, they have a new registration in this company, and now you have a termination but no new reassignment, how would you deal with that scenario?
I think a valid way would be to just stop these companies who doesn't participate in the system, and and then go the classic way. So when we get the new insurance or he cancels his insurance at CSS, this works against a stub, and this stub just fetch the data and delivers the old way. So yeah.
Well, I mean, you as CSS, you don't know where your customers go. You only know that they resigned with you, right?
Yeah, but we get a letter or a phone call or whatever else from the other company, so then we
So
know.
you don't need a third party again that would like them.
No. Just the ones who already exist.
Thank you for sharing. I was just a bit curious on the development of this proof of concept within your company. Did you analyze different use cases and you found this one to be the most efficiency saving, or?
we had a guy who did work with to find use cases. He made some interviews, but in this way we found other use cases. But this one was so spontan. One of the cases, our former CIO told us, and we thought it may be a good case.
So did you also make estimates on how much like workforce or efficiency gain we will have and how much savings you get out of this?
Not yet. You see, we are a little bit from the technical side. So first, we want to get knowledge about all this stuff to also be a partner for other firms or all these startups that will change the whole insurance system, and we can look at their contracts now. Okay.
Your problem doesn't seem too complicated to solve. What made you choose an permissioned blockchain over the public one?
First, one really big advantage is that you can develop on your own chain. So in this time, all these test chains had some problems and all this stuff you had. So that was a real advantage, not to choose from the business side, but to choose for development. That was an advantage. And I think every participant wants to have the whole knowledge, so he should have the possibility to run his node and get all the information he wants to out of there.
And insurance aren't companies who easily give their data array into a cloud or something. It's
Sorry, but can I ask one question regarding this? What data is available that would be seen in this part? Because it's not much data that you provide.
Nothing. It's just a hash, and the companies itself who owns their contracts, but it's nothing important. But insurers.
So like how you mentioned that basically the insurance company who has now the insurance contract, he would be able to see the social security number, which is the
only when this person re-signed his contract there or had a new insurance there, because then you have data beforehand outside of the blockchain available, and then you can save it with the generated hash.
You have a foreign key or a key on this store, and you just have the key.
Mm-hmm. But I basically, when I lose a client and I lose a client, then I have the hash plus the social security number, and then I see probably who gets the new, from where this goes to the new node.
And so you see it today, because you must inform the new provider.
It's when you save and when you register now, the telephone calls in the system.
And we had this second ID, which is the police number or something like that, that helps to get a better hash.
So we solved the hash with year and this contract number of the old provider, and so you only see this transition for this 1 year, for this one move of the customer, and nothing before and nothing after that. Yeah.
Actually, you want to expose some data as well, right? Let's say to the Gemeinde, if they want to know if somebody is insured, they publish or they request the HAV, and they say yes, he has insurance, yes or no. Those kind of information, that could be actually interesting.
Yeah, but that's not part of this solution.
Exposing a little bit of data might, and this is a consortium anyway, right? It's a closed environment.
Yeah, but you have to exclude the other insurance companies, so maybe a problem. You're? Okay.
So how do you allow companies to join the consortium? Do you assume that if they provide you the right hash because they know about the contract number, then they are allowed to take that person in terms of the law?
That's the algorithm is in the Docker container of the UI or
API.
Of the API, and so if he takes this one, he's assured that it's the. Otherwise, he has no chance to get a match.
It's hard to fake this data set, so this is the thing we want to achieve.
On the very highest rank.
How much time did it take you to implement all this?
3 persons, 2 weeks.
No, not 2 weeks. 1.5.
Yeah, perhaps you have done something between.
Okay, one question here. You also evaluate the cost benefits. For example, you spoke about intermediary, right? So when this intermediary is avoided, what are the cost benefits by introducing blockchain?
Verstanden.
Ja, was sind die finanziellen Einsparungen? Also, keine Ahnung.
Not my business. We have to convince the business. So perhaps it's about a little bit more than an hour. So I was happy to be there, and I had a great publicum. Thank you very much. And we will still be there to answer questions. And because nobody from the organization is here, I invite you to the apero.